we have done waves, or directly shall I go for the displacement? Should I just go for a glance and make you to understand, or should I start from where I had left? But what do you want to do?
Ma'am, I've sent the question in the physics WhatsApp group.
Okay, I'll check. I'll check. Should I start? Should I revise, or you understood the concepts? Okay, so that I can proceed.
Yes, ma'am, a little bit. Can you just revise?
Oh, fine. Then I'll start with this. So we have started with a periodic motion. Now, what is a periodic motion? A motion which repeats itself after regular interval of time. That is like your simple pendulum, or else if you want to understand it better, when the earth is revolving around the sun, right? This is periodic motion, because after every 365 days it comes back to its same position. So that is periodic. So a motion which is going to repeat itself, even the oscillation of a simple pendulum is periodic, right? If you consider there is no air friction, after every one, say, after a few interval of time, the motion repeats itself. So all these motions, we can take it as a periodic motion. Now, under periodic motion, there is a special type of motion, what we call it harmonic motion. It was. What do you mean by harmonic motion? The periodic to and fro motion in which the displacement, velocity, and acceleration can be expressed as a function of sine or cosine. Now, what is that? We'll just check for that, boys. Let me take your periodic motion. An example is your simple pendulum. Right, boys? No. In simple pendulum, what you should know is that when the simple pendulum is at rest, the position of rest we sometimes term it as mean position. Is that clear, boys? Then you displace the pendulum, right, to an angle theta. You're displacing it to an angle theta, which means you're applying a force. You apply a force, move the pendulum to an angle theta, say that will become your extreme position. So since you have displaced, there are two types of displacement. Theta is your angular displacement. Theta is the angular displacement. X is the linear displacement. Your pendulum has been displaced. There are two types of displacement: angular displacement, linear displacement. So when the body goes to the extreme position, your linear displacement X takes the value A. What is A? A, we call it as the amplitude. Amplitude means maximum displacement. Right, boys? Fine. Are you clear with this concept? Because I have to teach you what is harmonic motion. For simple pendulum, are you clear with this concept, boys? Mean position, extreme position, angle theta, angular displacement, x, the linear distance or the linear displacement x. X becomes equal to, takes the value A, where A is the maximum displacement the simple pendulum can have. Is that clear? Is that clear, boys? 11B, Derek, Dheeraj, Derek, Dheeraj.
Yes, ma'am, it's clear.
Yes, ma'am.
Okay. Fine. Now, see, the pendulum is oscillating, boys. The pendulum is oscillating. Say at t is equal to 0 seconds, it is at the mean position. Say at t is equal to 5 seconds, it occupies the extreme position. Now, what might be the displacement when t is equal to 1 second, right? What will be the linear displacement when the time is 1 second. What might be the displacement when time t is equal to 2 seconds, right? So the displacement at any instant of time, x a function of time. What is x a function? What is x? X is the displacement at any instant, right? The displacement at any instant means it can be at the second, it can be at the third second. What is the displacement of the pendulum? Say at the fourth second. That is the displacement of the pendulum at the fourth second, displacement at any instant. Now, how we do represent this displacement in terms of, I can represent the displacement in terms of a sine function or a cosine function. I can go for the cosine function. So the displacement of your simple pendulum at any instant, I want to find to what extent the pendulum has been displaced. Say at time t is equal to 2 seconds, at time t is equal to 3 seconds. So that is given as A is equal to cos omega t. Now what is cos omega t? This is called the argument of the cosine function. So you know that angular displacement was when the body, there's an angular displacement. When the body undergoes linear displacement, there is an angular displacement. Can you see this in simple pendulum? Boys, do you understand what is angular displacement? X is the linear displacement. X becomes your linear displacement. What is theta? Angular displacement. Since the body is undergoing oscillatory motion, it has both linear displacement and angular displacement. So now theta, what is angular speed? Theta by t. So what is theta then? Omega into t. So cos theta, I'm writing it as cos omega t. Are you clear, boys? Are you clear about this? Should I repeat 11b? Should I repeat, boys?
Ma'am,
Yes?
it's clear.
Okay, so the displacement, I'm just talking about the displacement, even velocity, even acceleration. If your displacement or your velocity or your acceleration, I can write this as a sine omega t. There's no harm in writing it in terms of a sine function. I can write the displacement in terms of cosine function or a sine function. Now, such periodic motion, we call this as harmonic motion. Are you clear, boys? The periodic to and fro motion in which the displacement, the velocity, and the acceleration of the oscillating particle, if you can express as a function of sine or cosine, then such functions, we call them as harmonic function. Fine? Now, do you understand what is harmonic function?
Ma'am, here A is the distance.
A is the maximum distance.
Okay.
X is the distance. Boys, suppose, look at this example. At time t is equal to 5 seconds, what is the displacement? The extreme position. At time t is equal to 5 seconds, what is the displacement? The displacement becomes the amplitude, maximum displacement. Maximum displacement is your amplitude. Are you clear, boys? So A becomes the amplitude. The amplitude means what? A is the maximum displacement X can take. What is X? X is the displacement at time t is equal to 1 second, time t is equal to 2 seconds, time t is equal to any n second. But what is A? A is the maximum value X can take. Is that clear, or should I redo this for you? 11b was a lot to be covered.
Ma'am, in this one, where's the acceleration? Like, does acceleration also need to be there in the same function?
Yeah, let us start only with displacement, otherwise you will get confused. When we finish your displacement, we'll go for velocity and then acceleration. Now I'm only concerned with your velocity. Here, don't take capital A as your acceleration, boys. Capital A is maximum displacement. Are you clear? Yes, capital A is the maximum value X can take. That is what we call it as the amplitude of wave. Sure? Or the amplitude of the maximum displacement is A. Okay, if you still feel fine, boys, just go for this, I think. Suppose if I go for this, right? The displacement versus time. I'll go for time. T and x. When t is equal to 0 seconds, x will be 0. When t is equal to 1 second, say 1 centimeter. When t is 2 seconds, this is 2 centimeter. I'm just, right? 3 seconds, 3 centimeter. 4 seconds, 4 centimeter. 5 seconds, 5 centimeter. This is the maximum. I'm just, this one. What is the maximum value x can take? Tell me, what is the maximum? It's after 5 seconds, boys, after 5 seconds, your simple pendulum will move in the opposite direction. What is the maximum value t can take? Sorry, x can take? 5 centimeters. Boys, after 5 seconds, the body will move to, yeah. So 5 centimeter becomes, 5 centimeter becomes the maximum displacement. So this value 5 is taken as the amplitude. Are you clear, boys? X is equal to a cos omega t. This a is, then what is x? This is x. X can be 1 centimeter, x can be 2 centimeter, x can be 3 centimeter. It depends on the value of t. That is why trigonometry, when you write a function x, what do you mean by this? X is a variable which depends on time. Now I saw you people were doing your trigonometric functions in your mathematics. There are two types of variables: dependent variable, independent variable. Do you understand what is dependent, what is independent? Now tell me of x and t, which is dependent, which is independent. X is displacement, t is time. Let me know.
Ma'am, time is independent.
Correct. Time is independent. What about x? Displacement is dependent. See, the value of x depends on time. When time is 1 second, displacement is 1 centimeter. When time is 2 seconds, displacement is 2 centimeter. Time keeps changing, right? But the displacement depends on the time. So time is not going, both are changing, but time is not going to depend on displacement. It's independent. Clear? But x depends on time. Fine, boys. Sorry. Harmonic motion. Do you understand what is harmonic motion? Do you understand harmonic motion, boys? Now, much to be done. The displacement of a particles at any instant can be written in terms of a sine function or a cosine function. Such motion we call it as harmonic motion. Fine. Next. Now, simple harmonic. We started with periodic motion. Any motion to and fro motion which repeats itself is periodic motion. There you went for harmonic motion. Under the harmonic, simple harmonic. What do you mean by simple harmonic? Now, boys, suppose if you have a rubber band, right? You have a rubber band, you're applying a force. You apply a force and stretch the band. You're stretching the band. So when you stretch the band, the moment you leave the force, the band wants to come back to its original position. You're stretching the band by applying a force. So the moment you stretch the band and you leave the applied force, the band comes back to its original position. Why? Because there is a force. We call this as the restoring force. It wants to come back. Such force we call it as a restoring force. So there will be a restoring force acting on the body. Is that clear, boys? And this restoring force, even in case of simple pendulum, boys, when the pendulum is oscillating, now the pendulum was at the position of rest, you have applied a force. Haven't you applied a force, boys? you have applied a force and the pendulum has been displaced in the direction of the applied force. This is your force applied. When you leave the force, what happens? The pendulum comes back to its original position, boys. The pendulum will travel back. Why? Because there is a force which is pulling it back to its rest position. We call this force as restoring force. Are you clear, boys? Are you clear what is restoring force?
Yes.
11. Only few boys are answering. What is the problem? 11B. So there is a force which tries to bring back the body to the rest position. We call it as restoring force. Now, what about the sign of these restoring force and the displacement? Are they acting in the same direction? Is the displacement of the body and the restoring force, are they in the same direction?
No, ma'am. Ma'am, opposite.
Are they?
They're opposite, right?
It's opposite direction. That is why your restoring force is proportional to negative of your displacement. What is X? X is the displacement. What is F? F is your restoring force. Your restoring force is negative. Negative means if restoring force is acting towards your right, displacement would have been towards your left. Is that clear, boys? Okay. What do you mean by F is proportional to X? F restoring. So the F restoring, what do you mean by that? F is proportional to X. Can someone explain in your own words?
Ma'am, if
Boys?
the restoring force, like if the displacement increases, the restoring force also increases.
It's correct. So if your displacement is greater, then to pull back the body to the original position, your restoring force should be greater. Yes or no? Boys?
Yes,
if,
ma'am.
if your displacement is more, to bring back the body from a maximum displacement to your position, you need more force. So your restoring force increases when the displacement is increasing, and they are opposite in direction. Now these are the two conditions. If these conditions are satisfied, then your harmonic motion can be termed as simple harmonic motion. F is proportional to minus x, or F is equal to k into x. What is k? It's a constant of proportionality. What does it mean? If your displacement increases 5 times, not necessary, your restoring force should also increase by 5 times. See, if displacement increases, restoring force will also increase, no doubt about it. But if your restoring force is increasing 5 times, your displacement increases 5 times, your restoring force might increase by 5 times or might increase by 3 times, or it might increase 10 times, but it increases. By what factor it is going to increase, that is given by what we call it as a constant of proportionality, K. We call it as force constant. Are you clear? And this K depends upon the nature, that we'll do it later. Are you clear, boys? What is a simple harmonic motion? A periodic motion, periodic oscillatory motion in which the restoring force is directly proportional to the negative of your displacement. Is that clear? Even that you can't say, boys. 11B.
Ma'am, could you
Oh,
change
it's
the last
clear,
one?
ma'am.
Ma'am, can you
Very
show
good.
the previous slide?
Yeah. Should I put in your chat box?
Yes,
Should I do that?
ma'am, I did that.
Okay, fine. Now, right? Now let us see how your displacement, right, boys? We have done, right, boys? Displacement of a particle executing simple harmonic motion, right? Nabil, is that fine?
Oh, yes, ma'am, it's fine.
Displacement of a particle executing simple harmonic motion. Okay, let's start with this. Displacement of a particle at any instant x is equal to, I'll go for, let me represent it as cos function. So where A is the maximum displacement, we call this as your amplitude. Okay. Because you know that the angular frequency is 2 pi by t. You can take it as angular velocity or angular frequency. I can take this as angular velocity. What is capital T? Time period, time taken for one complete oscillation. Is that clear, boys?
Yes, ma'am.
Okay. So how will I write x then? X becomes equal to a cos, what is omega? 2 pi by t into t. Is that fine?
Yes, ma'am.
Shall I go for the next one? Now let us plot displacement time graph, and then you will understand how your graph turns out to be a cosine graph. Shall I go for the next one, or you need time to complete?
1 minute, ma'am.
Okay. Shall I move on, boys?
Yes, ma'am.
Yes, ma'am.
Next, displacement time graph. Just write the heading. Displacement time graph. For simple harmonic motion, or SHM. Now this you people will do. So what is the displacement, boys? X is equal to a cos 2 pi by t into t, correct? Correct, boys? Okay. First one I'll do when your time t becomes equal to 0. Then what happens to x? X becomes a cos 2 pi by t into 0. So that is x is equal to a cos 0. You know cos 0 is 1. So x becomes equal to a. Is that correct? Is that fine, boys? Are you clear with this?
Yes, ma'am.
Okay. When t is equal to t by 4, t is any instant of time, any time. But what is capital T? Time taken for one complete oscillation. Are you able to differentiate between t and capital T? Was capital T is a time taken for it's a constant time taken for one complete oscillation. What is small t? Small t is the time taken, time at any instant. Now let us go for this. X is equal to a cos, I'm substituting in this formula, a cos 2 pi by t into, now t takes sorry. I'm substituting for t. Here t was 0. Are you clear what we are doing? So t becomes t by 4. So t and t will get cancelled. So x becomes equal to a cos pi by 2. Correct, 0. Cos pi by 2 is 19. Cos 90 is 0. So x becomes equal to 0. Are you clear?
Yes, ma'am.
Cos 90. Okay, next, will you be able to do when t is equal to t half? Others try this. So x becomes equal to a cos, which equation I'm using, boys? This one. This equation which I'm highlighting, I'm using this equation, I'm substituting for t. So a cos 2 pi by t. Now t takes the value t by 2. Correct? Anyone still having a doubt? Boys? Please answer. Do you have a doubt?
No, ma'am.
Okay. Cos pi means 180 degrees. What is cos 180? Minus 1. So what is x? X becomes minus a. Correct? Those who have completed this, the other values I'll give you. T is 3t by 4. Next, fifth one, t is equal to capital T. Can you do that? I'll wait for these students to complete. I'm writing the condition. Fourth one, I want you to go for t is equal to 3t by 4. Next one, t is equal to capital T for both. Can you find can you substitute the value and check?
Okay, ma'am.
Those who have completed, others complete. Can I erase the first one, boss? Can I erase the first one? First condition, shall I erase? 11b.
Yes, ma'am. Yes.
So first one I'm erasing. So I'm going for the next condition. So that is fourth one. When t is equal to, t is equal to 3t by 4. Okay. X becomes equal to a cos 2 pi by t into t becomes 3t by 4. So 2 goes 2 times. So x is equal to a cos 3 pi by 2. 3 pi by 2 is what? 270. So x is equal to a cos 270 degrees. That's 0. So x becomes equal to 0. This is the fourth condition. Almost it looks like.
Ma'am, so all these x values are they for one complete oscillation?
Yes.
Okay, okay, ma'am.
Shall I erase the second one? Boys, can I erase the second one?
Yes.
Can I erase the second one? I'm asking you, boss, shall I erase the second one?
Yes, ma'am.
Yes, ma'am.
Okay. Now, what is the next condition? X is equal to? What is the next condition, boys? Fifth one, when t becomes equal to capital T. So what is x? X is equal to a cos 2 pi by t into t. T and t, x is equal to a cos 2 pi. 2 pi is 360 degrees. So a cos 360 degrees. So that is 1. So that becomes a. Copy down, boys. Have you completed?
Yes, sir.
Shall I go for the next slide?
Yes, ma'am.
Start. Okay. I'll continue most probably if English teachers, I might come in the English period and then last period. I don't think so. It's so difficult for you to learn. So all trigonometric functions as the continuation of your max period only physics. Okay, boss, I'm leaving.
Thank you, ma'am.
Thank you, boss.